Hi everyone, so today we're going to be taking a look at Fish Speech text-to-speech model, and this text-to-speech model was created and is being maintained by Fish Audio. And the reason why we're taking a look at this right now is because 3 weeks ago the version 1.2 official release came out and I didn't get notified, so we'll be trying this right now. So right now we're going to be cloning Jarvis's voice from Iron Man, and this is a recorded audio of Jarvis's voice. So let's play it in VLC and hear how it actually sounds before we run the code to clone it.
Accessing alarm and interface settings. In this window, you can set up your customized greeting and alarm preferences. The world needs your expertise, or at least.
Now let's run the code and hear how it sounds when we clone Jarvis's voice from this audio file.
Hello world, my name is Megamind. I was designed by Austin Brain.
I'll be trying this right now, and I'll be dropping the link to this GitHub repo. This is their official GitHub repo. I'll be dropping the link to it in the video description, and I'll also drop the link to their official Hugging Face page. So just in case you want to download the necessary checkpoints from their Hugging Face page, you can do that without using Hugging Face CLI. And if you look over here, they said it was trained on 300k hours of English, Chinese, and Japanese audio data, which means you have no problem on those 3 fronts. And if you don't want to go through the hassle of downloading these checkpoints, I think there are about 6 files, and you don't want to go through the hassle of downloading them, you can install the Hugging Face Hub CLI Python package. And once you've actually done that, you can run this command. But make sure you do run it when you've opened your project directory in your terminal. So all you have to do is create a folder for your project and open it in the terminal and then run this command. So it will actually create this checkpoint /fish speech 1.2-sft folder and then download this. It will do all that at once, so you don't have to worry how to do it, but just run it in that particular project directory. So once you've actually done that and it's all downloaded, then you can actually open that folder in your IDE. You can use PyCharm or VS Code. I'll be using PyCharm for this particular tutorial. This video is just one in a series of videos where I do set up and I do talk about the different text-to-speech models that are available. And at the end of the day, once I'm done with all these videos, I'll be releasing a final video where I would compare each and every one of them to give you my recommendation on based on how easy it is to actually set up and how fast it actually runs. And for Fish Speech, this particular one, my advice is if you do want to use it for your AI system where it will generate audio from the text and the reference audio you actually give it, I would advise that you have a beefy GPU or at least a very, very good processor, because these actually use quite a lot of CPU power. And since I'm actually running it on my MacBook M1 Pro, it will take a while, the inference will take a while, and you do not need this huge latency when you're actually trying to generate speech from text, because you already have that latency when you're trying to get your LLM to generate text. So if you just want to use it for voice cloning, because this particular text-to-speech model can actually do voice cloning where you provide reference audio and provide text, then you have nothing to worry about because you have all the time in the world to wait. So let's jump right into the code. So as you can see over here in my IDE, I'm using PyCharm like I said, and as you can see we have modules directory which is in the root of my project folder, and I have Austin the wave, which is a recorded wave file of my voice basically, and we will actually try cloning it at the end of this video. But for now we're going to be trying out Jarvis the wave, and this is main.py where I will be calling the voice service class, which we will set up here. And since this video is part of the series I talked about, I'm going to set it up in a way that it's going to be similar to the code I actually wrote for OpenVoice and TTS and the rest of the text-to-speech engine I actually tried out. So you can just copy the function you actually need and paste it in, and if you followed my setup, it should work fine. So in this modules directory, that's where I'm going to clone the Fish Speech GitHub repo so we can actually install the Python package. Now, I don't think there's anything else. So now we can actually run this command. So make sure you actually have Hugging Face CLI actually installed, because you need to call it here, as you can see. And to actually install it, you need to actually follow this setup guide, and you have to install it this way. And as long as you have Python already installed on your machine, you can just run this command. So I'm going to be dropping the link to this guide in the description so you can follow it, and before you can actually run Hugging Face CLI, just in case you run into an error while running this command. And so once this is actually done downloading, okay, it is done fetching it. If we go over to checkpoint, as you can see, we have it here. So the next thing we're going to do is we're going to clone the repo, and we're going to clone it in the modules directory. So let's go over to your GitHub repo, and we'll copy this, and we'll right click here and open with terminal, and let's clone it. Okay, so next thing we're going to do is we're going to set up our virtual environment, and you can actually use virtual env or conda, but for me I'm going to be using virtual env. So to set it up, I'm going to, since I'm actually using PyCharm, I'm just going to go through the long process instead of running the command.
Hello world,
So
my name is
next thing I'm going to
Megamind.
do is
I was designed by Austin Brain.
I'm going to go over to the fish speed directory, which we just cloned from the repo, and open in terminal. And as you can see, our virtual environment is actually active, and I'm going to run pip. So this is documentation, and next thing we're going to do is since this is actually done installing, we can close this, open a new terminal in our root directory, and so for this part we're going to be using the terminal, and we're going to run 3 separate commands which will do 3 separate things. And one is going to generate the prompt from the voice, and the other one is going to generate semantic tokens from text, and the next one is going to generate the voice or the speech, however you want to call it, from the semantic tokens. So let's run the first command. Let's copy it, and so since we actually cloned ours to the modules directory and fish speech, we're going to copy this. Let's copy the path reference, copy from content root, and go back to the terminal and paste that in front, add a slash, and we are going to change the wave file since we actually have Jarvis.wave here. And now we can actually hit enter because we have a checkpoint in the correct directory, checkpoint fish speech 1.2-sft. So we can hit enter. Okay, we forgot to actually add the device because we actually have to use our CPU since we do not have CUDA device, or we are not actually using a GPU. But if you're using a GPU or CUDA, you won't have any problem with this command. So I'm going to add this. So it should run perfectly well now. So as you can see, we have saved an audio to fake.wave. Now that first command has actually run successfully. Now we're going to do the next one, and for this next one we are going to require the prompt text, and this prompt text is your reference text, as you can see over here. What you're going to do is the audio file which you actually passed in here, you have to actually transcribe it, or if it's your voice, you do know what you actually said and you have to write down the text whatever you actually said in this WAV file, or you can just transcribe it using Whisper or something. So that's what you actually need to do. You can also transcribe it manually, but it's definitely up to you, but that's what you need to actually pass in here. And for the text is what you want to actually, the text you want to convert to speech. This way you're going to do it. So you're going to pass it in here. So let's go back to our IDE and we'll paste that in. And I'm going to change the prompt text. And I'm going to paste in the text transcription from the audio. Let's point this in the correct direction. Let's do what we did earlier. So let's add the text that we want to convert to speech. And since we're actually not using CUDA, next thing I would advise you to do is remove this compile and add half. And we would also add so make sure you actually change this to device. But don't worry, I'm going to be pasting this command and all the command I actually used in my terminal. I'm going to be pasting it. I'm going to create a README here in this repo, and I'm going to paste it there. And I'll also make the repo available. So in case you're actually following this video, you can just clone the repo and run everything as I actually run them. So it's going to generate 2 samples, and now it's generating the first one. I need to generate the second one also. Okay, it's done, and it generated codes_1 and codes_0.mpy. So next we're going to run the last command, and we're going to use the first sample. You can actually use the second sample, but let's just use what they used. Paste it, and let's do what we did earlier. We're going to copy this, copy the path, and we'll path from current root. And now we're going to paste this here. And this is like the first command, but the input path we're passing in is this. So let's run it. Oh, forgot to actually add device. So let's add the device. So it has actually saved the audio to fake the wave, and if we go to our Finder or your File Explorer, fake the wave, and let's play it with VLC.
Hello, Austin Brain. How are you doing today?
Okay, we had something horrible at the end, but that's okay. We can actually try out the second sample.
Hello, Austin Brain. How are you doing today? My name is Megamind.
Okay, that's perfect. And this is the original wave, and let's play it.
Accessing alarm and interface settings. In this window, you can set up your customized greeting and alarm.
So it's really close, and that's really good. At least it's actually way better at cloning voices than Open Voice version 2, because it's almost like it's really close to the original voice. even though it's not perfect, but it's really close. When you're actually running the second command, you can add in quite a lot of parameters. You can actually tweak it a little bit. You can change the temperature, you can change the top P, you can do a lot of things. You can change the chunk length, I think so. Yeah. Because if we go over to this file, generate.py, you're gonna see what I'm talking about. So let's go over here and go to tools. Okay, not there. You can change the chunk length, you can change the temperature, you can assign top P, you can pass in a lot of arguments, and so it's definitely up to you to play around with it. And the next thing we're going to do is create a class. So I'm going to paste in some code. Let's refactor this. So let's refactor this to fish speech. So now if we go over to generate, you're going to comment this out. If we go over to this, comment this out so it won't run any commands, because we are going to be calling the main function. So the next thing I'm going to do is I'm going to paste in two different functions here. So I'm going to install and import Pygame because we'll be using it to play this particular WAV file that we're going to pass in here, and we can also remove it, but I'll leave this commented out. And so let's go over this. So for this first one, what we are doing is generating the prompt from voice, and the second we are generating the semantic tokens from text, and for the third one all we are doing is generating the speech or the audio from the semantic tokens. So, and this is one of the samples, and we're going to use the second one so we won't get the active artifact we got the last time when we used the first sample. And for this, let's add a path and let's pass in text here. Let me pass in what Jarvis said. So now what we're going to do is go over to our main.py and we're going to import So this error is because it can't actually locate the module, because when we actually ran the installation, fish speech was not named like this. So the directory name was practically different. So let's open this in our terminal again. And let's run. So it should run this and use this directory. Okay, now let's close it. So let's run it again, and this time it should run.
Hello world, my name is Megamind. I was designed by Austin Brain.
And as you can see, it's actually done playing, and it saved the audio to output/output.wav, and if we go over to our outputs directory, we'll see output.wav. So, and if you want this to automatically remove the file, you can remove the comment from here and it will remove the temporary audio file. And I don't think there's anything else. Hold on, hold your horses. I know I actually said that there's nothing else to do and we are going to call it a day. But before you do that, this is the ghost of Austin's past. So basically, I made an error. I actually called the wrong function here in main.py. Previously we actually called the play function, which is actually incorrect. We're supposed to call the fish speech function that we created in voice.py. As you can see, that is where we will pass the text, not in play. The play function only takes in the temporary audio file. So the moment you actually correct it, you won't have any problems. I know you might have actually run into this issue, and I'm sorry about that, but now you can actually go back to what you were doing. Bye. And hold on one more minute. So I said earlier in this video that I'll be cloning my voice, and since I have Austin the Wave here already, that's what I'm currently doing. I have passed in the text, and I have also changed this to Austin the Wave in the voice.py. I've also passed in the reference text, which is the text I actually recorded into Austin the Wave. So that's basically what I said when I was recording that particular audio. So let's hear it and see if it actually sounds, even if it's 70% like me, if it can actually sound 70% like me, then it would be really awesome.
Hello world, my name is Megamind. I was designed by Austin Brain.
Wow. It's not bad. Like, it's not bad. It sounds like me, maybe 60%, and you can actually judge for yourself. So that's gonna be it for this video, and thank you for watching. And do not worry, I'm gonna be dropping the link to this repo in the description, in the video description, and I'll also drop the link to the other videos where I actually set up Open Voice version 2. I also set up back TTS. I also set up Piper TTS and Melo TTS. So I'm gonna be dropping the link to those videos in the description. So thank you for watching, and make sure you like, subscribe, and share.